Hi everyone, here is our Somerset Math Circle Club Lecture 9. Today we're on topic 9. We have 3 parts. Here is the first part, ratio, conversions, and rates. Ratio, we compare 2 or more quantities. It's a relative comparison of 2 quantities. So it does not have to involve absolute numbers, but you can see relatively how big or how small the 2 things compare. We'll use some examples later on to show you. Conversion factors is a factor that we use to convert measurements from one unit to another. For example, gallon to quarts. Rates is what we in general we call that speed or velocity in this case, and we have distance and time, how we convert in between the 3 quantities. Practice problem 1. Simplify below ratios. 9/6. So this is ratio 9, and between 9 and 6, the ratio basically is 9 divided by 6 or 9/6. Mathematically, these are all the same. So if you know how to do 9/6, and we can simplify top and bottom with the common factor. If we divide top and bottom with the same number, and we end up with a 3/2, and this is the ratio would be 3/2. This is the simplified version of this. Students can either use this one or this version to do the calculation. This version sometimes is easier if you are dealing with the fractions, as we'll see in the second example. So this easily we can write it as 1/2 divided by 1/3. Divide a fraction, that is multiply the reciprocal of that fraction, that's 3. So that's 3/2. The ratio is 3:2. And this is a decimal. We can convert the decimal into a fraction form first. 0.4 is 2/5. So that's 1/2 over 2/2. These are mixed numbers. We want to convert them first to improper fraction. And this is 7/5 ratio of 12/5. So this, you can change that to a division. Then you multiply the reciprocal of the second fraction. So 7/5 multiply 5/12. Then you would get 7/12 as the ratio. We'll leave this problem for the students to figure it. This is basically exactly the same as this version. And now we have 3 numbers, the ratio of 3 numbers. Now you don't need to do, or better not to do the division, because there are 3 numbers that can easily confuse you. So 3-number ratio, we look for the common factor of the 3. So we look at this, okay, 3 is a common factor. Then we can divide 3 from all 3 numbers. So that would end up with, first one divided by 3, you're left with 3, 12, you're left with 4, 21, you're left with 7. So here's the final ratio. Fraction form, 3 numbers. The ratio now is a little bit more complicated than this. Instead of a divide, you do a multiplication of their the LCM of their denominators. Here you have 2 and 3, so the LCM of 2 and 3 is 6. So we multiply every single number by their LCM. So 1/2 multiply 6, 2, 1/3 multiply 6, 2/3 multiply 6. So you cancel, first one is 3, second one is 2, the last one is 4. So here's the final ratio. The last example is almost exactly the same if you look at 2 numbers as the example that we showed earlier. Again, you convert everything into improper fraction. 10/3, 17/4, 26/5. Now you look for, now F and G are the same. You look for the LCM of 3, 4, 5, which is LCM of 3, 4, 5, which is 60. You multiply every single fraction by 60. And that would give you the final ratio. I'll leave the final answer for the students to figure out. Problem 2. Kevin's candy jar has 56 pieces of candy. He only has butterscotch and jelly beans, and the ratio of the two beans is 5 to 2. Kevin likes jelly beans more, and he wanted to add some more jelly beans so that the ratio between the two is 2 to 1. How many jelly beans should he add? Okay, total have 56. So if we divide this 56 into 2 piles, and the number of those are 5 to 2, which means the total are 7 shares. Among them, 5 shares are the first kind, and 2 shares are the second kind. So we divide 56 into 7 shares. Each share are 8 candies, right? So then the first kind, the butterscotch, has 5 shares, therefore there are 40. The second kind, which is the jelly beans, it only have 2 shares, therefore is 16. If we want the final ratio to be 2 to 1, that means the B kind over the J kind is 2 to 1. Now the B kind is 40. How many we need for the jelly beans? So if that's 2 parts and this one is only 1 part, so 1 part of a 40 is 20, right? So the jelly beans has to be 20 in order for the ratio to be 2 to 1. So jelly beans now you have 16, therefore the difference is 20 minus 16 to 4. Problem 3. My water-sized photo of my pet is 3 centimeter wide and 5 centimeter tall. If I want a larger photo to put on my wall and I want the area of the photo to be 135, the new one, then how many centimeters wide should the larger photo to be? Okay. This is the original photo. It's 3 by 5 centimeters. We want to enlarge this photo. Remember, if we enlarge this area, both width and height will increase, right, by the same factor. Not the same amount, but the same factor. If we say we enlarge the rectangle to this big, and this new width is going to be x times bigger than 3, right? 3 times x. And the new height is going to be the same fashion. So the 5 would be x times bigger. So the new area is 3x multiply 5x. This would equal to 135 centimeter square. So this is a 15x squared equals to 135. We need to find the x. So x squared, 135 divided by 15 is 9. So 9, what square equals to 9? X equal to 3. So we have to increase both width and length by 3 times. And the question asks, well, how many centimeters wide should the larger photo to be? So now the ratio, the factor is 3. So now this width is 9. The height is going to be 15. Practice problem 4. The density of water is approximately 8.3 pounds per gallon, and there are 4 quarts in a gallon. How much does 7 quarts of water weigh? Okay, 8.3 pounds per gallon. Per gallon, in 1 gallon there are 4 quarts. So 1 quart is 8.3 pounds over 4. Now you have 7 quarts. This is how much it should weigh. So we can first find 1 quart, the weight of 1 quart, and then multiply the 7. Problem 5. An inch is approximately 2.5 centimeters. Approximate how many square centimeters are in a square inch. So This is a conversion problem. 1 inch equals to 2.5 centimeters. If you want to be really precise, it's 2.54. So 1 inch square, that's 1 inch multiply 1 inch. That is 2.5 centimeter multiply 2.5 centimeter to give you centimeter square. This is 6.25. Practice problem 6. A freight train travels 1 mile in 1 minute 30 seconds. At this rate, how many miles will the train travel in 1 hour? In this problem, you can have different ways of solving this. 1 minute 30 seconds, you travel 1 mile. In 1 hour, there are 60 minutes. Okay, 60 minutes divided by 1.5 minutes is how many times? It's a 40, right? So in 60 minutes, you can travel 40 of this much. Therefore, the total would be 40 miles. The other way of looking at this problem is you figure out what the speed is. So the speed is just rate. Rate is what? Distance over time. Distance is 1 mile. Over how much time is 1.5 minutes. Okay, that's the speed of this train. So 1 mile over 1.5 minutes. Now, distance equals to speed multiplied time, right? Therefore, distance is speed 1 over 1.5 multiply how much time? 60 minutes would give you the same answer. Practice problem 7. If you walk for 45 minutes at a rate of 4 miles per hour and then run for 30 minutes at a rate of 10 miles per hour, then how many miles have you gone at the end of 1 hour and 15 minutes? What is your average speed? Okay, first part of the question. If you walk 45 minutes at this rate, so how much distance within that? So 45 minutes, because the unit is different, miles per hour. Now you have minutes. Let's convert the time into hour. 45 minutes equals to 3/4 of an hour, right? Therefore, 3/4 of an hour time multiply speed give you distance. Therefore, this is 3 miles. This is the first part. Second part, run for 30 minutes at a rate of 10 miles per hour. Again, unit doesn't match. 30 minutes, convert that into hour, 1.5 hours. Therefore, 1.5 hours at the speed of 10 to give you distance. Therefore, this is 5 miles. Total, therefore, you run or walk combined is 8 miles. That's the first half of the question. Then the second part is asking you, what was your average speed? What is the definition for speed? Total distance over total time that you used to complete that distance. Total distance now, after the two parts, you get 8 miles. How much time? 1 hour, 15 minutes. Let's convert this into hours. So 8 over 1/4 hours. So 8 divided by this is 8 multiply the reciprocal of the improper fraction of this. Improper fraction of this is 5 over 4. Therefore, is you reverse that. That would give you the final average speed for miles per hour. We'll leave for the student to figure the final answer out. Problem 8. Ben leaves his house at 7 a.m. and bikes at a constant speed of 15 miles per hour due east. A leaves 100 miles due east of Ben, leaves her house at 8 a.m. and bikes at this speed. And what time do they meet? Okay, so Ben leaves here, A leaves here. Ben leaves 1 hour early, okay, goes this way. And A leaves an hour later, coming this way. Okay, let's say first hour, how much distance Ben has covered. So 1 hour, it travels 15 miles. So Ben is here at 8 a.m. That's 15 miles, okay? Total distance between A and B is 100. Therefore, the remaining distance is 85. Now at 8 a.m., both of them are traveling toward each other. When they travel toward each other, their speed should add up, right? So their total time to meet is 85 miles divided by the addition of their speed. So what is the addition of their speed? Ben leaves at 15 miles per hour. A travels at 10 miles per hour. So therefore, their combined speed is 25 miles per hour. What's the total time for them to travel this 85 miles? That's 85 divided by 25, okay? This is in hours. And this hours add to the 8 a.m. would give you the time that when they meet. So this is, we believe the students can figure this out. If you cannot do, this hours is going to be in decimal form. You convert the decimal into minutes, then would give you the hour and the minutes. Add that to 8 a.m. would give you the answer. Problem 9. Rajiv's car has tires that have circumference of 75 inches. How many revolutions or turns will his tires make if he drives to a store that is a quarter mile away? Okay. Here is the tile. When the tile goes forward, it goes one turn, that is, the wheel goes one full circle, and that one full circle's distance is 75 inches, is the circumference of the tire. So if you travel total distance of 0.25 miles, basically this is how many of the cycles, how many of the revolutions. Each revolution equals to its own circumference. So it's a division problem, 0.25 divided by 75 inches. But this is in miles, this is in inches. You can't divide it like that, right? And here we have a conversion factor. 0.25 miles equals to 0.25 miles multiply 5280 feet. And feet is not in inches. How many inches are in 1 foot? 12. So by doing this conversion, multiply a quarter mile to this factor would give you the final answer in inches. And this answer divided by 75 is how many turns. So eventually you would have 0.25 multiply 5280 multiply 12 divided by 75. That would give you the final, how many revolutions over this quarter mile. Problem 10. The cold water faucet of a bathtub can fill the tub in 15 minutes. The drain, when opened, can empty the full tub in 20 minutes. Suppose that the tub is empty and both are open at the same time. How long will that take to fill the tub? So if you want to fill the tub in 15 minutes, and this rate to fill is 1 over 15 minutes. The drain, the speed for the drain is 1 over 20, right? And now they both are open. Fill is a plus number. Drain, you're going out, is a negative number. So they kind of cancel each other, but not quite, because this number is bigger than this. When they go opposite ways, we do velocity as a difference, V of drain. So now the fill-in speed is the difference between the two. 115 over 1 over 20. This is the actual speed. Now we are filling the tub because some of them are drained. And to fill the whole tub, let's say the workload is 1. So basically 1 over the actual speed would be how many minutes you would need. 1 over 115 minus 1 over 120. the students can figure this final number out. This is eventually how many minutes you would need now to fill the tub.